Hey everyone, in this lesson we're going to be talking about linear regression, causation, and correlation. So that is the title for today, linear regression, causation, correlation. I will explain to you guys what all of this stuff means in a minute. But first of all, I want to go over and review what is a point and how do we graph points, because we're going to be doing a lot of that when we gather data to be able to do this in class practically. So a point is also known as an ordered pair. So they use this mathematics interchangeably. So they can say like graph this point or graph this ordered pair or the set of ordered pairs, blah, blah, blah. It is given by two values, the x and the y. So the x basically is given because that falls on the x axis, and the y, that whatever number is given falls on the y-axis. So the x-axis is the horizontal line that's in the middle running through the center or the origin. The y-axis is the vertical line that runs up and down running through the middle or the origin. So the key word here is origin. We always start at the center. That center point right here is known as the origin. Every single time when you want to graph a point, you want to start at the origin. So if the x is negative, you move to the left. If the x is positive, you move to the right. You can see that here because the negative numbers are on the left and the positive numbers are on the right. Same way for the y. If the y is negative, we move down. And if the y is positive, we move upwards. So same thing here. Basically, you can tell because all the positive and negative numbers, the positive numbers are on top, the negative numbers are on the bottom of this origin for the y-axis. Okay, so the axis, the axis are basically the lines that run through the middle or the origin. We always start at the origin when we want to graph points. So first is left, right, then is up, down. Okay, that being said, let's practice graphing some points really quick. So first I'm going to graph this point, which is -1, +1. -1 on the x-axis means that first I'm going to either move left or right. So since I look at this, on the x-axis is going to be -1, which means I got to move to the left one. On the y-axis, I have to move in the positive direction, which is up 1. So this means to the left one, and this means up 1. So then my first point when I graph it is going to be to the left one, up 1, which is going to be right there. Okay, that is my very first one. Let's do the same thing with the point 1, 1. Same idea. So if I look at 1, 1, on the x-coordinate, I have a +1. On the y-coordinate, I have a +1, which means that if I start on the origin, which means the middle, right, I have to go to the right one because it's positive, and then up 1 because it's positive. So starting here, I go to the right one, up 1, and there's my point. Okay, if I keep going using the same pattern, this is how we always graph points. So let's say I want to graph this one now. So I look at the x and the y coordinate. The x coordinate is 0, and the y coordinate is going to be at +2. So I always start at the origin. So starting at the origin, I'm going to be 0 to the left or to the right, which means that I don't go left and I don't go right. I stay right in the middle. So it starts in the middle, and then we go directly up 2. So 1, 2. This is my next point. Okay. If I want to graph a different point, well, let me pick a different color for this. Let's say I want to graph the, wrong one. Let's go with this one. So let's say I want to graph the -2 and the -1. So on the x coordinate, I have to go -2. On the y coordinate, I have to go -1. So all that means I have to go to the left 2 because it's negative, and then down 1 because this is also negative. So x means left, right, y means up or down. So to the left 2, down 1, that would start in the middle always. Left 2, down 1, that would be right there. And then I have 2 more. I'm going to go a little bit faster now since you guys kind of got the hang of it already, hopefully. So this is 2, -1. So on the x-axis, we go 2. On the y-axis, we go -1. So the x-axis means left or right. In this case, we're going to be going to the right because it's +2. And then the y-axis, we're going to be going down because it's -1. So we start in the middle always. To the right 2, down 1. That would give me this point right here. Okay, and we're almost done. Last but not least, let me make this black. So on the x coordinate, I have 0. On the y coordinate, I have -1. So if I want to graph this point, I have to go 0 on the x, meaning I don't go left or right. I stay right in the middle. And then I go down 1 because it's negative on the y. So I stay in the middle, and then I go down 1, which is right there. Okay. If I connect this dot, all these dots, so if I connect everything together, what shape does it make? So let me just connect them together real quick. So this connects to that, this connects to that, this connects to that. Why did I do that? Because there's a question on the bottom that says, what shape does it, oh, sorry about that. What shape does it create when you connect the neighboring points? And the answer to that is a triangle. So basically, essentially what we just reviewed is how do we graph points, because we're going to be needing to graph points when we look at linear regression, causation, and correlation. Okay, now that we know that, so correlation describes the size and relationship between two or more variables. So correlation has the word relation in it because it basically means that stuff is related to each other. So the variables are related in some way, shape, or form. So let's look at some examples really quick in terms of correlation. You probably have seen this before in the past, and if not, this is what is called a scatter plot. So a scatter plot is basically just a series of dots or a series of points that are scattered in a graph in a way for us to be able to identify whether or not there is a relation or not. So the question is, does studying increase your grade? So we have here on the x-axis the study time in hours, and on the y-axis we have the math grade. So as you can see, if the more the person studies, it seems to be, or the more a person studies per day, it seems to be like their grade goes up linearly. How do we know that? We know that because we can see that as we go to the right, as the study time increases, the math grade increases. So as study time increases, math grade increases. Now, since they both increase, that is what we call a positive correlation. So as you can see from the bottom here, I actually have this already written out as positive correlation. So the reason why it's called a positive correlation is because if I were to draw a line, an imaginary line, this line actually has a name, and I'll explain the name in a little bit. If I were to draw a line through these points, as close to the points as possible, this is called the line of best fit. But again, it's just an approximation. Maybe this is not the best line. You want the line to go through as many points as possible, or you want the line to be as close to as many points as possible. So maybe this will be the line that's a little closer. Since the slope of the line is positive, right? So if I go from left to right, it looks like this person is going uphill, right? So this person's traveling uphill. Then that means that it's going to be a positive slope or a positive correlation. Okay, so that's all that means. Can you have a negative correlation? Absolutely. So let's look at an example of something like that. So in this case, we have an example of the price of peaches versus the number sold. As you can see, the price of peaches, as the price of peaches goes up, the number sold goes down. So as the price increases, the number sold decreases. This is what is called a negative correlation, because rather than this line going upwards, this line seems to be going downwards, because as the price increases, the number sold decreases. This makes sense, right? Like if you go to the store and you want to make some like a peach pie, and you go there and then a bag of peaches costs $10, you're like, oh crap, I'm not gonna buy peaches today. Like that's ridiculous. Let's go check out the apples. Let's see how much the apples are. Maybe we can make an apple pie. So usually those two things are related, right? So the price of peaches, as the price of peaches goes up, the number sold goes down. So this is a line that I drew. Again, this is called the line of best fit. You always want to draw this line as close to the middle or as close to the point as possible, going through as many points as possible. The idea here is that the line should be as close to every single point as it possibly can. And this is called the line of best fit. Will you get a perfect line of best fit every single time? No, not if we're doing it in class. Everybody will have something that'll be a little bit off. But essentially, the important thing here is that you can see that the slope of this line is actually negative, right? Because this line, instead of it going uphill, it's actually going downhill. So if I have my little guy that or girl that is traveling, in this case, from left to right, like you're reading a book, downwards, right? So from left to right is going downwards, downhill. Therefore, this is a negative slope. Therefore, this is a negative correlation. That being said, there is one last example. So if we have a bunch of dots here, let's say, for example, we have two things that are not related or not correlated. So we have, in this case, the hours of sleep and the hair length. Are those two things related to each other? Like if I ask someone, hey, how long did you sleep? Will the people that have long hair always say more than the people that have short hair? In this case, the answer is no. There is no relationship, right? So those two things are not related to each other. That's why these dots are all over the place. So since these things are not related to each other, there is no relationship or no correlation, right? So no relationship. Therefore, there is no correlation. And it's good that the word relation is inside of that correlation because you kind of get an idea of what exactly it is that we're talking about here. Okay, as I said earlier, when you draw a line across the points that are actually related or correlated with each other, there is a difference between stuff that is really, really bunched up together and stuff that is not bunched up together. So in the first one, we have an example of a strong positive correlation because as you can see, all these dots are really, really close to each other. And it seems to me like that is really, really clear that it is going up, right? The slope is going up for this line. So if we draw a line of best fit for something that looks like this, the point, yes, we do have a positive slope. Yes, we can draw a line of best fit, but the points are not as close to that line of best fit. Therefore, we have a weak positive correlation. Similarly, we can have a strong negative correlation if the dots are close together, but the slope is going down. We can have a weak negative correlation, same idea, if the slope of the line is negative, but the dots are not as close together to the line as they would be. And then here we have a moderate negative correlation, right? We can have a strong negative correlation, but we can have a moderate negative correlation as well. Here the dots are pretty close to the line, but it's not perfect. Ideally, you want them to be as close to the line as possible, preferably like every single point being on that line. That would be ideally negatively or perfectly negatively correlated. Since not all the dots not all the dots are on the line or not very close, then it's not as strong. So we have moderate relationship here. Finally, we have no correlation whenever the dots are not forming a line, either up or down in any way, shape, or form. Okay, so that means most likely that the stuff is not related at all. So that is what correlation is: positive correlation, negative correlation, and it gives you an example of what scatter plots are. So now let's talk about correlation coefficient. So these actually have what is called a correlation coefficient. And correlation coefficient is basically defined by the letter R, lowercase r. I don't know why they picked R. They just decided to use R, maybe R for correlation. I have no idea. So the correlation coefficient is also called the R value. Ooh, this thing does not want to stay. So the R value, and that is a way to measure how close the points are to each other and whether or not there's a positive correlation, negative correlation, or no correlation. Ideally, what the R value represents, let me make this brighter. The R value represents either it's a value between 0 and 1, or actually I should say it's a value between -1 and +1. +1 meaning that it's a strong positive or perfect positive correlation. -1 means perfect negative correlation. So the R value goes from -1 all the way to +1, and it can be equal to -1 or +1, but it cannot be less than -1. It cannot be greater than +1. right? So on the left-hand side, if we have perfectly negative 1, that means that it's a perfect negative correlation. And all that means is that every single point is on the line and it's going downhill. In this case, we have a perfect positive correlation. And all that means is that every single point is on the line and it's going up. So that's how we measure correlation. That's how we quantify it. It's called the R value, the correlation coefficient. So this is some example of R values. So for example, here we have a strong negative correlation, right? So the value is negative for R, but it is really, really close to -1 because if we draw a line, the points are pretty darn close to that line that I drew. The correlation coefficient here, let's say I draw a line here going through, you can tell that it's going downhill also, right? However, not all of the points are close to the line. So it is a negative correlation, but it is a weak negative correlation. The correlation coefficient is not as strong, meaning that it's a lower number. So it's -0.5. An example here in which we have no correlation is here. All the dots are scattered, right? And it doesn't seem to be like, I can't draw a line through this going up or down from left to right. So there is no correlation here. And as you can see, the R value is 0. So let's move on to this right here. So here we have some dots that are going uphill. As you can see, I can draw a line going up from left to right, always from left to right, like you're reading a book. So in this case, there is a relationship going uphill, but the dots are not that close to the line as they should be. So it is a weak positive correlation. The R value is actually 0.5. Let's look at this next example. We have a strong positive because if I draw a line through these points, it's a positive slope, positive correlation, and then all those points are really, really close to that line. So therefore, the R value is 0.9. And then finally, last but not least, I have the R value of 1, which means that it is a perfect positive relationship. As you saw, perfect positive relationship is when the R is equal to 1, meaning that if I draw a straight line, every single point falls. Oh, that is a terrible example because I can't draw straight lines, guys. Bear with me. Every single point will fall on that line. So there you go. That's an example of every single possible scenario and what it's going to look like. So let's answer the questions. What the sign represents? The signs represent either a positive slope or negative slope on that line of best fit. So basically, if the line of best fit goes down, that's a negative slope. If the line of best fit goes up, that's a positive slope. What does the value of the number represent? So the R correlation coefficient number, R represents the closeness. Is that even a word? God, thank God I'm not an English teacher. R represents the closeness to the line. And then finally, can the R value be greater than 1? Can it be less than 1, -1? The answer for this is no. It can only go up to +1 and then down as far as -1. 0 would mean there's no correlation. Okay, so if you see the words correlation coefficient or R value, that's exactly what it means. It means how close are these points to each other. So if it's negative, that means it's a negative slope and they're really close to each other if it's a high number. If it's positive, that means it's going to be a positive value and it's going to be a high number, as in close to 1 if they're really close to each other. And if there's no correlation, it would be a 0. Okay, hopefully that puts everything into perspective for you guys. Okay, so causation. The last thing that we're going to be talking about is causation when we're talking about correlation and stuff. So we already talked about correlation. Now let's talk about causation. Causation, you already know what it is. It's called cause and effect. It indicates that the result of something happening is directly related to another event, just like cause and effect, right? So if I push, I don't know, if I'm pushing someone on a swing, right? I push someone, and then as a result of me pushing them, the swing moves, and then they have fun on the playground. So that would be an example of cause and effect. But it can apply for any other thing. So for example, one of the examples that I have here is: do ice cream sales cause the temperature to rise. If they cause something to happen, that means that there is causation. So the cause and effect, right? So if something causes something to happen, that means that there is causation. So let's write that down. So there is causation if something causes something else to happen. So it's a direct relationship, right? Something causes something else to happen or cause an effect. Let's look at this example. Do ice cream sales cause the temperature to rise? As you can see, is there a correlation here? So let's look at this methodically at this scatter plot. So there is a positive correlation. So there is a relationship, right? Because as you can see, if I draw a line going through these points, let's say I draw a line going through most of these points, pretend that's a line and it's perfectly straight. Use your imagination. So if I draw a line through these points, I can see that it's a positive slope, therefore it's a positive correlation. And it seems to be like, if I were to guess that R value for this, I would say the R value would be about 0.8 because it's really, really close. The numbers are pretty close to each other. They're not perfectly on the line, but they're pretty close to each other. So I would say that it's pretty strong positive correlation. Um, However, is there a causation? That is the key thing here. Is there a causation? Do the ice cream sales cause the temperature to rise? You can see that there's a relationship, right? The hotter it is, the more people want ice cream. But let's say, for example, I live in Southern California, but I'm originally from somewhere really, really, really cold, and I like it cold. And I don't want to be wasting AC. I don't want to waste electricity. So I'm like, okay, I don't want the sun to come out today. So therefore, I'm not going to buy ice cream. If I don't buy ice cream, then the sun won't come out. Does that make any sense? No, right? The ice cream sales does not cause the sun to come out. It's actually the opposite. So in this case, there is no causation because there is no cause and effect. Just because of the fact that these two things are related doesn't mean that one causes the other. So if I don't buy ice cream, doesn't mean that the sun will not come out the next day. So just be careful. There may or may not be a relationship, but that doesn't mean there may or may not be causation. So those are two different things. So let's look at this. Do high temperatures cause more ice cream sales? In this case, yes, right? High temperature causes more ice cream sales. So there is causation when it comes to temperature causing the ice cream cells, but there's not when it comes to ice cream cells causing temperature. So be very, very careful. That's exactly the difference between looking at correlation and causation. So let's look at this example. These two things are also related, right? If I draw a line of best fit, so let me draw a line of best fit. So from left to right, I'm trying to get as many points in there as possible. Pretend it's a straight line. So I would say that there is positive relationship. So there is a positive correlation. So that's one thing. I can also say that the R value is pretty close to about last time, right? About 0.8. It's pretty strong positive. So I'm going to say the R value is about 0.8. Estimated, of course, because I don't know for sure. The question is there causation? Do the sunglasses cause ice cream cravings? Now, there is a relationship between around a certain time of the year, let's say summer, ice cream sales go up and sunglasses go up, but that is not because one causes the other, right? They both are affected by the sun. So the sunnier it is, the more people buy sunglasses. And as a result, the hotter it is, because the sunnier it is, then the more people buy ice cream. So these two things are related to each other, but they're not a direct result of each other. So in this case, do sunglasses cause ice cream cravings? So no, they do not. So there is no causation. Um, does ice cream cause sensitivity to sun? So no, the ice cream does not cause sensitivity to sun. So there is something else at play here, right? So these two things are correlated, but it doesn't mean that they're directly there's direct causation or cause and effect between these two things. So be very careful. Some statisticians use this to their advantage sometimes to justify things that are happening. They say, "Oh, look, this is happening, therefore this is happening. Look at this nice graph." And you have to be more mindful about data. There's a reason why data is very, very important nowadays. Facebook, Instagram, Google, they all take your data, the data of millions of people, and they use that data to advertise and to basically um, persuade people into one thing or another based off these graphs. So be very, very careful. Do absences cause low grades? So let's look at this. So we can see that the course average, if I draw a line of best fit, I want to make sure I draw a line as close together that connects these points as possible. So there's my line of best fit. Now let's say the first thing we need to say is that the R, actually no, let's look at the correlation. The correlation is negative because the slope of the line is going down. So negative correlation. The R value seems to be going down. It seems to be pretty close to the line. So let's say I'm going to estimate about R value to be a negative number now because it's going down. Let's say 0. I don't know, 0.85. This is a guess. So in the future, you look into like more specifically how to get that R value, but we're not going to discuss that in this class right now. And then finally, we just have to figure out, okay, does one cause the other? Is there causation? So do the number of absences cause low grades, or do low grades cause the number of absences? So let's answer this question. Do low grades cause absences? So I can tell you for a fact that there are people that show up to every single day to class and don't do anything. So that is absolutely not true. So low grades are not caused by absences necessarily. They're caused by effort and how much work someone does. So in this case, there is no causation, meaning no cause and effect. So the negative grades there's something else at play, right? So basically, it doesn't mean that just because someone is absent, they're going to get a low grade. If they come the next day, if they get their missing assignments and they do the work, they might get a better grade. But ideally, the more people are absent, the lower grade they have because the more catch up they have to do, or maybe they get a lower grade because they turned it in late, or maybe some teacher doesn't take late work, so their grade does go down. So even though there is relationship, it doesn't mean that there is causation. So no cause and effect. Lack of RAM, depending on the teacher, of course. Lack of RAM. And so let's look at this. So forget about that for a minute. Let's look at this bottom portion here. So everybody has a cell phone nowadays, or not everybody, but most people. Let's look at correlation. So every time your phone freezes, your text messages don't work. And then when your phone isn't frozen, your text messages work. But when your phone freezes, your text messages won't work. So there is a correlation between when your phone is freezing and your text messages not working, right? But just because there is correlation, doesn't mean that is a direct relationship or direct causation between these two things. It could be that the phone is freezing because of lack of RAM, right? So if you don't have enough RAM and you're trying to open YouTube, blah, 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 and you have Netflix and you have like Instagram and you have other social media running in the background, and you don't close any of the apps, the phone freezes and therefore your text messages won't work. But you may say that, hey, this is a result of that. However, it may be that there's an underlying other factor here that's actually causing it, meaning the lack of RAM. So the moral of the story is sometimes there is causation, sometimes there is no causation, sometimes there seems to be causation, but there's something else at play. So does no correlation imply no relationship? Not necessarily. Okay, so I hope this video was informative. I'll see you guys on the next one.